In a class of senior high school students, 15 have pet cats, 12 have pet dogs, 5 have both cats and dogs, and 8 have neither cats nor dogs. How many total students are in the class? For these kind of problems we use a Venn diagram to represent the information. Let C denote the set of students with pet cats and D denote the set of students with pet dogs. The intersection part represents the students who have both cats and dogs as pets. This section represents the students who have only cats and not dogs as their pet. And this section represents the students who have only dogs and not cats as their pet. Given 5 students have both cats and dogs. Therefore, it can be written in the intersection section of both sets. Given that 15 students have pet cats. Therefore, number of students who have only cats is equal to 15 minus 5, which is equal to 10. Also given that 12 students have pet dogs. Therefore, number of students who have only dogs as their pet is equal to 12 minus 5, which is equal to 7. It is also given that 8 students have neither cats nor dogs as their pets. Therefore, it can be written outside the Venn diagram. Therefore, total number of students in the class is equal to number of students who have only cats plus number of students who have only dogs plus number of students who have both cats and dogs plus number of students who have neither cats nor dogs. Therefore, total number of students is equal to 10 plus 7 plus 5 plus 8, which is equal to 30. Therefore, there are 30 students in the class. How many 4-digit numbers can you write if you are not allowed to use any digits except 0, 1, and 3? Since we are limited to using only the digits 0, 1, and 3, and we want to form 4-digit numbers, there are 3 choices for each digit place except thousands. For thousands digit place, there can only be 2 choices 1 or 3 because 0 cannot be written as the first digit. For hundreds place, there can be 3 choices 0, 1 or 3. For tens and units place as well, there can be 3 choices, 0, 1 or 3. Therefore, to find the total number of 4-digit numbers, you must multiply the number of choices for each place. Which implies 2 times 3 times 3 times 3, which is equal to 54. Therefore, you can write 54 different 4-digit numbers using only the digits 0, 1, and 3. In a bag, there are 4 red balls and 6 blue balls. If 2 balls are drawn randomly without replacement, what is the probability that both balls are red? Let's denote the events. R1 is drawing the first ball as red and R2 is drawing the second ball as red. We want to find probability of R1 intersection R2, the probability of both events happening. Initially, there are 10 balls in the bag, 4 red plus 6 blue. So, the probability of drawing a red ball on the first draw is probability of R1 is equal to number of red balls divided by total number of balls, which is equal to 4 by 10, which is equal to 2 by 5. After drawing 1 red ball, there are now 9 balls left in the bag, 3 red plus 6 blue. So, the probability of drawing a red ball on the second draw is probability of R2 given event R1 has already occurred is number of remaining red balls divided by total number of remaining balls, which is equal to 3 divided by 9, which is equal to 1 by 3. Now, the probability of both events happening is the product of the individual probabilities, which implies 2 by 5 times 1 by 3, which is equal to 2 by 15. Therefore, the probability that both balls drawn are red is 2 by 15. At a theater, there are 30 rows of seats. The first row has 20 seats, and each row behind the first has 2 seats more than the row in front of it. The last row has 78 seats. What is the total number of seats in the theater? Since every row behind has 2 seats more, the total number of seats in each row can be represented as an arithmetic series, 20, 22, 24 and so on till 78. Therefore, we need to find the sum of the numbers in this series to find the total number of seats in the theater. Using Gauss's method, we will first write down the sum of the numbers in the series S in the forward way. Then, we will write down the same sum in the reverse order. We will then add the numbers in pairs in both the series. You will notice that each pair of numbers adds up to 98. Therefore, we can write it down as 2s equal to 98 plus 98 plus 98 and so on till 98. Since there are 30 rows, there would be 30 pairs of 98. Therefore, 2s is equal to 30 times 98, which implies s equals 30 times 98 divided by 2, which is equal to 15 times 98, which is equal to 1470. Therefore, total number of seats in the theater is 1470. How many times does the digit 7 appear from 1 to 85? Efficient way to solve these kind of problems is to first divide the numbers into 3 groups. First group, containing the numbers that have 7, only in unit place. Second group, containing the numbers that have 7, only in tens place. And third group, containing the numbers that have 7, both in unit and tens place. Therefore, there are a total of 7 times digit 7 appears as only unit digit. 7, 17, 27, 37, 47, 57 and 67. There are a total of 9 times digit 7 appears as only tens digit. 70, 71, 72, 73, 74, 75, 76, 78, and 79. There are a total of 2 times digit 7 appears as a unit digit as well as a tens digit. 77. Therefore, total number of times digit 7 appears from 1 to 85 is 7 plus 9 plus 2 equals 18. The sum of 3 consecutive odd integers is 63. Find the integers. Let's denote the 3 consecutive odd integers as n plus 2 and n plus 4. Notice that the difference between consecutive odd integers is always 2. According to the given information, the sum of these 3 consecutive odd integers is 63. Therefore, n plus 2 plus n plus 4 is equal to 63. Which implies 3n plus 6 equals 63, which implies 3n equals 57, which implies n equals 19. Therefore, the 3 consecutive odd integers are 19, 21, and 23. Thank you for watching.